Hello dear students, in this video I am going to prove the theorems 8.9 of your chapter Quadrilateral. Theorem 8.9 is very important and it is also necessary for the class 10, so give concentration and try to understand it. So theorem 8.9 is that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. The line segment joining the midpoints of two sides, that means in a triangle the line segment joining by two midpoints of any two sides will be parallel to the third side. Suppose if triangle ABC, the midpoint of AB is suppose E and midpoint of AC is suppose F. The line segment joining these two midpoint is EF. The line segment joining by these two midpoint is EF. We need to prove that this EF is parallel to BC. So the same is true for any two sides. If we take the midpoint of BC, then this line segment, if we draw line segment here, this line segment will parallel to the remaining side, that means third side. So here we have taken the midpoints of side AB and AC as E and F. So this side will be parallel to the remaining side, that means BC. We need to prove this one. So let's start it. First of all, write what are given in the theorems. First of all, write, let in triangle ABC, as we have considered the triangle, so I am writing let in triangle ABC, the midpoints of AB and AC are E and F respectively, So we need to prove what we need to prove. EF is parallel to BC. This EF is parallel to BC. We need to prove it. So for that we have to construct something. So construction is that construction see carefully. Here we will draw a line through C which will be parallel to AB. That means suppose this line, we will draw a line segment or ray, suppose CM, this one, and this CM is parallel to AB. It is constructed in such a way that CM is parallel to AB, and we will extend this EF to meet the line segment CM, suppose at G. Give it D, D. Now see, alright, line segment through C, a line segment CM is drawn such that CM is parallel to AB or AB is parallel to CM, and EF is extended to meet CM at D. This is D. EF is extended to meet CM at D. So let's see proof section. In proof section, proof. Now see, first of all we will consider these two triangles, triangle AEF and triangle CDF. AEF and CDF. In these two triangles, if we observe, see, this AB line is parallel to CM, no? So if we consider AC as transversal, then this angle and this angle will be alternate angle. Or you can consider this one is as transversal, this line and this line is parallel. If ED is considered as transversal, then this angle and this angle will be what? Alternate angle, and alternate angles are equal in case of parallel lines. So these two lines are these two angles are what? Parallel or equal, and these two angles are equal, vertically opposite angle, no? And in triangle AEF, this side AF, and in triangle CDF, this side CF or FC, this AF and FC are equal. Why? Because F is the midpoint. Whenever there is a midpoint, then the two parts become equal, no? So in first of all we will show these two triangles congruent. Very easy. So first of all, write in triangle AEF and triangle CDF. Why I am taking CDF? Why not CFD? See, angle A is equal to angle C. So as I have considered first A, so here I have to consider first C. And angle D will be equal to angle E will be equal to angle D, no? Because they are alternate. So after A I have considered E. So after C I have to consider D, because E and D are equal. And the last one is same, F. In order is very important in case of similarity and congruence of triangle. Note it. Now see, in this two triangle, angle, this one angle, suppose EAF. In case of angle, you may take any order, no problem. And in triangle, in this triangle DCF, why they are equal? Alternate angle. Similarly, this angle and this angle are what? Equal. In triangle AEF, AFE angle is equal to DFC angle. DFC, vertically opposite angle. You will write in full form, vertically opposite angle. That means this angle, this angle and this angle are equal, and this angle and this angle are equal. Again see, AF is equal to FC, no? AF is equal to FC. Why? Since F is midpoint, no? F is midpoint. So that means three corresponding parts become equal. So we can no doubt we can say that these two triangles become congruent. Therefore triangle AEF is congruent to triangle CDF. By what criteria? See here, angle, this angle, and their included side. That means angle, side, angle. By angle, side, angle criteria, we can say that the two triangles are congruent, no? So since they are congruent, see, we know that for two congruent triangle, all the corresponding parts are equal. That means we can write now AE is equal to DC, AE is equal to CD, no, or DC. Therefore we can write AE is equal to CD, no, AE is equal to CD, CPCT. Now see one more thing, AE is equal to EB also, yes or not? Yes. Also what can we write? AE is equal to EB. Why? E is midpoint of AB, no? If E is midpoint, then their two parts are equal. Now see, from these two equation, A is equal to CD, A is equal to EB. That means these two side will be equal. That means CD will be equal to EB. Yes or not? CD will be equal to EB or BE. Therefore we can write CD is equal to EB or BE. No, EB or BE. Yes or not? Yes. Now see, BE and CD becomes what? Equal. And also since AB is parallel to CM by construction, so AEBE will also be parallel to CD. That means parts of the parallel lines are also parallel. This is the part of AB, this is the part of CM. So parts of parallel lines are always parallel. So we can say that BE is parallel to CD and they also become equal. So when in a quadrilateral one pair of opposite side will be parallel and equal, then other pair will automatically equal and parallel. That means this quadrilateral EBCD or CDEB is a parallelogram. Why it becomes parallelogram? Because in this quadrilateral DEBC, EB is equal to DC and they are both are parallel also. So we can say that DEBC is a parallelogram. So right, how will you write it? Right, in quadrilateral EBCD EB is equal to DC or B is equal to DC and EB is parallel to DC. Therefore we can write EBCD is a parallelogram. No? Now see, since EBCD becomes a parallelogram, EBCD becomes a parallelogram, so we know that in a parallelogram both the opposite pair of sides are parallel. These two sides are parallel, it is by construction, and EBCD becomes a parallelogram. That means the side ED will also be parallel to BC. When ED will be parallel to BC, then EF will parallel to BC. That's it. So right, therefore we can write ED is parallel to BC because opposite side of parallelogram are parallel. Opposite sides of parallelogram. No? Therefore we can write, since ED is parallel, since ED is parallel to BC, then EF will be parallel to BC because the parts of parallel lines are parallel. This is one part of ED, so parts of parallel line is parallel, so EF is parallel to BC. It is proved. Therefore EF is parallel to BC. Proved, no? Proved. So theorem 8.10 is exactly reverse theorem of the theorem 8.9. so you will prove it by yourself and you will send me in my WhatsApp number. Thank you. Don't forget to like, share and subscribe my channel.